Morning, everyone. On probably next week now, you're going to be getting a test on common assessment on forces, gravity, in particular gravity, also potential energy and kinetic energy. So, going to be reviewing a fair bit throughout the next few days. And what we have here are two just review exercises, some of the things we've done. So here it is, if I can show you this one. There you go. And what we're going to do is just go through some of these. I'm not going to be giving any answers as such, but maybe some guidance. So, first question, what is the acceleration rate at which all objects fall to Earth? That one is blindingly obvious. So, there's only one number there that should mean anything to you. Everything else doesn't mean a thing. So, that's a straightforward one right there. 2. If an object falls for 2 seconds, what would be its velocity as it falls to Earth? So the key thing in the question there is it falls over 2 seconds. The SI unit that we're probably going to be using is meters per second. It says it right here. So if you've got the information for 2 seconds, what's it going to be for 1 second? Question 3, motion energy. What's another name for that? Again, this is one of those that just requires some memorization, but it begins with the letter K. How's about that? All right, question 4. Calculation of momentum. So the first thing you need to do is think to yourself, right, well, what's the formula that we're going to use for momentum? And that's just another one of those things that requires studying and memorization. So, discuss among yourselves what that might be. And here it is. So you can see that momentum formula is P equals m times v, P being momentum, m being mass, and v being velocity. So looking again at your question, question 4, you've been given the mass, morning, 453 kilograms. You've been given the velocity, which is 5.2 meters per second. All you need to do there is just multiply those two across and you get the momentum. Now, if they don't give you the units, you need to combine both units. So it's going to be kilograms times meters per second. Question 5, friction. What do we call friction as it occurs in the air? So there's the key thing right there. What is the name of that resistance that is in the air? Question 6, find the potential energy of a 62 kilogram brick sitting at a height of 454 meters. So the first thing you need to do is, again, figure out that formula for potential energy. So this is going to be your formula here for potential energy. So it's gravitational potential energy. Because of that, you need to include first the mass of the object, second, gravity, the acceleration caused by gravity, which is 9.8 meters per second squared, and then finally we multiply that with the height. That's it. All right. So again, then we go on to question 7. Again, we look at question 7. You've got the cannon there. First thing, when you look at this, it says action forces, reaction forces. So the first thing that should come to mind there is Newton's third law of motion. For every action force, there is an equal and opposite reaction force. And all you do is you think to yourself, right, well, what force comes first? So which is the force that initiates things? And of course, that is the cannonball coming out. And that causes an equal and opposite reaction in the cannon itself, pushing backwards. Just like when you turn on the hose at home. When you turn on the hose, the action force is the water coming out. The reaction force is that you get pulled back slightly. Ask anybody who's a firefighter. All right. Question 8 is more of a history question. It says, which of these scientists believe that the mass of an object did determine the time it would take to hit the ground? Well, who proved that that was wrong? So that's the first thing. Who stated that mass has no effect on how fast things fall to Earth? By looking at that, you can tell for sure one of those three is not the correct answer. Then you've got a choice between those other two. Again, that might be worth you investigating that. Just Google it really quickly and you'll find out the answer. Question 9. The higher up an object is, the greater potential energy. Is that true or false? That one, I don't know. I will actually jump off that building if you don't get that one right. And then finally, number 10, another name for Newton's first law is the law of inertia. Again, use the clue in the question. Clue is Newton's first law. So what is Newton's first law? Object at rest stays at rest. An object in motion stays in motion. Both of those things indicate that there is a resistance to changing the motion or changing, staying put. That resistance to change is inertia. So again, Newton's first law, inertia, they make sense that those two go together. Okay, back to this one. This is very much going to help you with the common assessment itself. And again, first question relates to potential and kinetic energy. And again, this is interpretation of a bar graph. So just by looking at that, you should be able to tell by looking first at the actual position of the marble, let's say, on the roller coaster itself, in addition to the actual bar graphs that are underneath that coordinate with it. So this bar graph goes with this one up here, this bar graph goes here, this one goes here, this one goes here, and so on. Alright, and by doing that you should be able to see the relationship between potential energy and kinetic energy and be able to tell where both are at their maximum. There are some questions. For example, question 3 asks, state the law of conservation of energy. At this point I don't mind you looking that up, but you should have an idea that those words right there, no, created, destroyed, transferred, are keywords in that definition. Then finally, number 4 asks you to calculate the kinetic energy. Well, first thing we have to do is find that formula. So again, if I look down here, so if I can get this working, and maybe there it is. Alright, so just by looking here, maybe there it is. Can you see that? Let's have a look. Maybe that isn't going to work. But it basically says, because I can't see it there, it's kind of annoying. Let's see if I can get rid of that. There it is. So if you look carefully, and I drag that down a tad, kinetic energy equals half of the mass times the square of the velocity. Alright, so m is mass, v is the speed or the velocity, and you should be able to do that calculation knowing that. Again, feel free just to divide the mass by 2 to get the half, and then just multiply it by the square, which is the number times itself. And you should be able to get the kinetic energy for question 4 there. Okay. All the others should be relatively straightforward. There's 2 calculation questions, 4 and 5, so you need to know the formula for kinetic energy to do that. Question 6 asks you about mass, what will happen to the kinetic energy. Question 7 asks you in that light bulb there, what happens, how does the electrical energy get converted, what energy does it get converted into? Again, just by looking right here, if I can get my finger in the right spot there, you should be able to see what the 2 types of energy are. Okay, and then again down at the bottom here, if I can show you, there it is. Potential energy is again mass times gravity times height. Okay. And again, a lot of this work here is review. I'll be happy to help you in real person with that. And then finally, there are some terms and some definitions of things we've been doing for the last few weeks that's going to be very helpful to you in these common assessments coming up. I think that's it.